Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 7-4, Similarity in Right Triangles. We have some prior knowledge we need to review before we get into today's lesson, which is complicated, and then we have our normal vocabulary and important information to go over as well. So let's go ahead and get started with a right triangle, and we want to go over the different parts of this right triangle. So remember that this little box over here in the blue means that that's a right angle, which makes this a right triangle. And the side across from the right angle is always known as the hypotenuse. And the hypotenuse is always the longest side of a right triangle. The other two sides of a right triangle are known as legs. So you'll have two legs and one hypotenuse in every right triangle. Now we want to go over the idea of an altitude. An altitude, of course, in our regular lives would be like how high you are up in the sky when you're, flying or something like that. How far away are you from the earth? But an altitude in geometry always starts at a vertex and goes across the shape at a 90-degree angle to the opposite side. So this red line I've drawn here is an altitude of this right triangle. And we're going to use altitudes in this lesson. And then the last bit of prior knowledge is an arithmetic mean. In our real lives, the word mean, of course, could be that's a mean person, they did something mean-spirited, something like that. In arithmetic, a mean is an average. So if I wanted to find the average of our ages or the average of something, you add them all together and divide it by the number of things you added. A geometric mean is what we're going to talk about in here today, and that's a little bit different. All right, so let's go ahead and work on a geometric mean. We were doing proportions earlier in this quarter, and if you may have noticed that when we do our cross product property down here, some of the ways that those are known as is the means and the extremes. So for our geometric mean, this is the kind of mean that they're referring to. So when you have that proportion there and you cross product property, you get x squared equals AB. And if you wanted to solve this for x, to get rid of the square, you have to square root. And what you end up with is that x equals the square root of AB. And all that really means is you're taking the one that doesn't happen twice, because the x happens twice, and you're going to multiply those together, a times b, and take the square root. And that's the geometric mean. All right, now let's cover our theorems. Our first one here is Theorem 7-3. It's the right triangle similarity theorem. And what it says is that if you have a right triangle and you create an altitude of that right triangle, it divides that triangle into two smaller triangles that are similar to the original and to each other. So let me show you what I mean here. Here's our original right triangle here in red, and I like to call this the Papa triangle. And then they draw an altitude here in yellow, and that turns this into two smaller triangles. There's the baby triangle there in yellow and the mama triangle there in blue. And the baby triangle is similar to the mama triangle in blue and the Papa triangle in red. The mama triangle in blue is similar to the baby and the Papa triangle, and the Papa triangle in red is similar to the baby and the mama triangle. So all three of these triangles are similar to each other. From that theorem, we get two corollaries, and the corollary is just something that follows right along after. So the first corollary here talks about that altitude that you draw in the right triangle, which I've highlighted here in red. Here's our altitude. And what it says is that the length of that altitude is the geometric mean of the lengths of the segments of the hypotenuse. So this altitude breaks the hypotenuse into two pieces. One piece here in blue and one piece here in yellow. It breaks it into those two pieces. And the altitude, A, is the geometric mean of those two pieces. So if the blue piece of the hypotenuse had a length of 4 and the yellow piece of the hypotenuse had a length of 9, you could set this up as a proportion, and what you'd get is that a squared would equal 4 times 9. And then you could solve this using algebra. You would get a squared equals 36, and then you would take the square root of both sides, and you would get that a equals 6. The altitude here would be 6. And that's how you use corollary 1. Our second corollary is a little bit more complicated, but all you need to know is that for this one, we do use the smaller triangles that the altitude breaks it into, but we're not actually talking about the triangles. What happens is we're going to use the leg here in green, or the other leg here in blue of the Papa triangle. If we call the green leg here X and the blue leg here Y, they become the geometric mean of the hypotenuse. So for the green leg X, you take the part of the hypotenuse that's the closest, that's adjacent to the leg you're talking about, and you times it by the whole hypotenuse, the whole thing. And what you get here is that x squared would equal AD, the small part of the hypotenuse that it's adjacent to the leg, times the whole thing AB. And the same thing holds true if we were to look for part y here. Y squared would equal BD, the small part of the hypotenuse that's adjacent to it, times the whole hypotenuse. And that's corollary 2. It's a very complex system, you guys, and I wish you the very best of luck. Have a great day.